Hi to everyone that just joined. We will wait just a minute or two. It's just after 10 o'clock where I am in Boston, so give it a few minutes for stragglers to join in. But in the meantime, if you have any questions, feel free to submit them in the Q&A widget, and we can queue those up for our speaker, Sharon, in a few minutes. But for now, we're just going to give it another minute or two for folks to arrive. That one we can do a little bit. For those who are just joining now, we're going to give it maybe one more minute and then we will get started. And in the meantime, you can ask questions in the Q&A widget. Thanks to Jack for already submitting one. Okay, I think we can get started. Thank you for everybody for joining this morning. We're going to have a brief presentation with overview of Formlabs Materials, and then most of this webinar will be open Q&A format with Sharon Soong, who's the head of R&D materials, or head of materials R&D, excuse me, at Formlabs. I've known her and worked with her for years. She's a fantastic resource, so bring all your questions. We're going to focus on SLA. If you have questions about other types of materials, we may be able to answer them as well. Feel free to drop them in the chat now or throughout the presentation. To start with, Formlabs has the mission to bring tools that make it possible for anyone to bring their ideas to life. The company was started in 2011 with a successful Kickstarter campaign with the Form 1 in 2013, and since then has expanded to 800 employees with 300 plus engineers and scientists, offices all over the world, and more than 130,000 printers shipped and out in the world. In service of that mission, we make printers, materials, and the accessories, consumables, services, software that are required to use them. And we operate in SLA, which is stereolithography, 3D printing, and SLS, which is selective laser sintering, a form of powder bed fusion, all in the polymers space. And so of this wide array, today we're focusing on SLA materials, so one quadrant, if you will, of Formlabs' overall business. Here's an overview at a glance of the SLA materials available. We split them into different families: the general purpose family, engineering family, dental and medical materials, materials for casting, investment casting of metal parts, and then Form X is our experimental line. Not experimental, I guess, more like advanced workflows, and we'll look at some of those in a moment. Thank you to those who are adding questions in the chat. Feel free to keep those coming. I'll talk for maybe 5-10 minutes, and then we'll hand it over to Sharon. So the general purpose materials that I mentioned are, I think a lot of the time they get compared to PLA for those who are using FDM 3D printing, because it's the most accessible, most straightforward workflow. But the mechanical properties of the materials pictured here and the general purpose materials from Formlabs are more comparable at this point to a entry-level engineering plastic like PETG. So they are not general purpose as in insufficient for engineering purposes. They are general purposes as in they're versatile. They balance stiffness, toughness, strength, impact resistance, all of these different qualities, whereas you'll see some of the engineering materials are formulated to optimize for one or the other, or a few of these characteristics. So these are going to be your general purpose daily drivers, if you will. Tough materials get requested a lot. Toughness being the amount of energy a part can absorb before it fractures, which is often a trade-off with stiffness. So if we see higher stiffness on the left here, tough 2000, where 2000 is the tensile modulus of the material in megapascals. And then on the other side, we have, so stiffness, higher stiffness, lower toughness on the left, but still within the tough family, so they're still pretty good. And then higher toughness, lower stiffness, more ductility on the right. If you'll indulge me, I can share a little bit about the latest material from Formlabs, Tough 1500 resin, which I have one of the parts pictured with me here. It is real. This was announced a couple weeks ago. It's available now for pre-order. If you want to get your hands on one of the samples, we have this belt buckle, and you can request one of these for free on the website. We'll mail it to you, and you can get a sense physically of the properties that I'll talk about for a quick second here. If you've used Tough 1500 resin from Formlabs before, this is a different beast. Tough 1500 resin had pretty high notched izod as one of the tests, but pretty lower fracture toughness compared to this new material. So it takes 10 times more force applied to fracture the part. You can see the crack propagates much more slowly or with much more force applied. Oops. And it's also got higher Gardner impact strength, which is more about the toughness of a thin sheet. And so with Tough 1500 version 1, it had a tendency to, it could absorb a decent amount of strength when the parts were thick, but thin parts were more brittle. The new formulation is performs much better on toughness at thin geometries. Looking beyond the library of tough materials, we also have some rigid materials. This is actually the same nomenclature as with the tough family. So the number 4,000 and then 10,000 is the tensile modulus of these materials. So these are higher stiffness, lower toughness. Both of these materials are glass filled, and so they also tend to have higher temperature resistance. And a bonus feature, really, really nice surface finish. Rigid 10K in particular looks and feels almost like stone. It's a favorite. I can definitely say it's a favorite for printing in the Formlabs offices. On to softer elastomeric materials. These ones are named based on their shore hardness, which is the amount that you can kind of impinge into the material. So a lower material means a lower shore hardness rather means it's a softer material. So silicone 40A being the softest, flexible 80A being more of a stiff, soft material. If you think about the difference between like a rubber band would be a softer elastomer, and then like a pencil eraser would be a tougher, or like a shoe outsole would be a tougher, soft, flexible material, or a stiffer, flexible material, excuse me. We have additional materials that enable a particular application or material property. So high temp resin has the higher heat deflection temperature. Flame retardant resin, which you see in the GIF here, is self-extinguishing. This is UL94 Blue Card certified material. And then ESD, which is a static dissipative material for working with electronics and other sensitive devices that are sensitive to static electricity and static charge. I briefly mentioned castable materials earlier. We have clear cast resin is the one that you can see here in the front. These are for printing large investment cast pieces for engineering properties, or engineering parts rather. And then castable wax resin is more used in jewelry and dentistry for small parts. These would take the place of wax in a lost wax casting process, where this is the master pattern and then it gets put into plaster investment and burned out so that metal can be cast in its place. We also have a range of dental materials, which are rather niche. If folks here have questions about dental materials, we can get into that. And I know some of the pre-submitted questions had to do with the biomed materials, which we can get into biocompatibility in the Q&A section as well. Lastly, I mentioned Form X, which is the novel chemistries and multi-step workflows. Alumina 4N is a technical ceramic material, and the PU Rigid 650 and 1000 materials are hybrid chemistries. So these are genuine polyurethane materials that really push the bounds of what we were talking about toughness and stiffness earlier, and the polyurethane materials, which have, as mentioned, a more complex workflow, totally change the game in terms of what mechanical properties are attainable with SLA. We also recently introduced the option to print with any 405 nanometer resin on Formlabs SLA products. So with open material mode, here are some examples of real Formlabs customers who formulated their own materials. They have their own materials R&D, which our host Sharon obviously knows very much about. And it's been really cool to see what customers are using Formlabs products for, where they have access to the reliability and the build quality of Formlabs products, but their own either novel chemistries or certified workflows, that sort of thing. One question that I think we're going to get a lot is, how do I find the right material for fill-in-the-blank application? And the general framework is that I would recommend to anybody to start with is first define your performance requirements. What does the part need? Does it need to be able to be dropped from chest height onto a concrete floor? Does it need to be able to flex 10,000 times? And then think through how you would translate that into material requirements. If it has to be dropped from chest height onto a hard floor, that would be toughness or tensile modulus or impact strength. And if it has to be flexed 10,000 times, that's flexural strength and flexural wear. And then you can start to look at the library of materials available, whether that's Formlabs materials or other, based on your material requirements. And if you're looking for data on Formlabs materials, I highly recommend this page, where there's filters on the left that you can use. Actually, if you were to scroll down, but this is a screenshot, so I won't, you can filter on specific mechanical properties. So if you are half listening to me and half doing other things, you might be interested to open up formlabs.com/materials and play around with that tool. And with that, we'll go into Q&A. We'll start with some questions that were submitted ahead of time, thanks to those who were able to do that. And then we'll get to the live questions. I'm really glad to see we have a lot going on here. So this is Sharon Soong, my colleague, head of materials R&D at Formlabs.
Hello, everybody.
Thanks, Sharon, for joining us today. We'll go through we'll start with some pre-submitted questions. So one viewer is looking for a resin that matches injection molded polycarbonate.
That is very hard. I don't think we have something that will really match a injection molded polycarbonate today.
Yeah, and I would go back to this question of what quality specifically of polycarbonate are you looking for? Is it impact resistance? Is it rigidity?
Optical trend, like clarity. Yeah, so I think to Eliza's point, there are different resins that can meet partial requirements of a polycarbonate. Today we don't have a single material that can really meet all the performance metrics of a polycarbonate, which is pretty high performance thermoplastics from thermal, optical clarity, as well as impact resistance perspective.
Yeah, and if you have follow-up questions, you know, if it is the optical clarity or the stiffness or something else, feel free to reach out to Formlabs, the sales line. We have sales engineers who would be happy to discuss your particular application with you. What are some steps to mitigate warping of geometrically complex parts in unspecified material?
Yeah, so in general orientation, as well as taking care of your post-curing steps is the strategy that we take internally to mitigate warping. So warping comes from, like really coming from different steps of the printing process. Our photopolymer is a cross-linked material. So as is curing in the printer, you will have some shrinkage, and the only way to mitigate that is through orientation. And so the best way is to tilt it in both in XYZ, so that in every given layer you're mitigating the given layer shrinkage. And then as you look at your post processing, don't let it sit too long in your IPA, as it absorbs too much solvent. It can soften the parts and further induce warping. Make sure your part is properly dried before your post-cure process. Oftentimes, if your geometry is more important than your end property, you can choose to post-cure at a lower temperature to really get the surface cure, reduce all the tackiness. And sometimes if you go through a longer heat post-cure, it could induce more warping as well. And so internally, what we typically do is really going from the print setup all the way through the post-processing to help in reducing warping. Post-processing specifically, people often have more success in keeping the geometry when they're post-cure on support as well. Support structure tends to hold your geometry in how it was being printed and help you mitigate some of these warping problems.
Definitely. Another question is, how does the heating chamber in Form Cure and Form Cure L, affect the quality of the print versus curing at room temperature? How does curing with heat affect the material?
Yep. So as I mentioned a little bit earlier, all of our resins follow polymer. They're cross-linked. In polymer, there is this important metric is called glass transition temperature, which is the temperature where your polymer started to soften. So unlike thermoplastics, you will have a melting temperature, your material will flow. In a printed part or post-cured parts, our material will soften but not flowing because it's a cross-linked system. And so for our polymer or for the resin to get to your ultimate mechanical property, we often need to post-cure with light when the temperature is slightly above the glass transition temperature. That's why for different resin, we often recommend a different temperature setting to heat up the green part to close or slightly above the glass transition temperature that will enable more cross-linking to happen when the light turns on. And so it is our lever to push the formulation matrix to get to a better conversion, meaning cross-link completeness. And that typically helps us to get to the ultimate mechanical property. Room temperature tends to have the reaction will happen slower, which means you may get a little less stiff parts, but the part will still be functional if your application is okay with like slightly less conversion and less stiffness of the part.
Yeah, I have an illustration here of the reaction that happens during the post-curing process. So the short answer is that this reaction will happen more quickly if the post-cure happens at an elevated temperature, but with the trade-offs that Sharon mentioned. Cool. With that, we can go to some of the live submitted questions. To start with, is silicone 48 actually silicone?
Yes, it is actually silicone.
What can you share about how this also novel chemistry works and a little peek behind the curtain for viewers at how that development process went?
Yeah, so there are a lot of silicone-like resins out there, basically using a silicone backbone, but the functional group is still your traditional acrylate methacrylate, so it's easier to go through like photo curing, photo cross-linking. We are able to really use a true silicone backbone with just the binding function, which is typically what you see in your two-part silicone. And we're able to develop a very unique, we call like a silicone cross-linker that allow us to build a true silicone backbone. Formlabs actually has a public patent on this material. And so if you're really interested in the chemistry, you can look up the patent that we have, which talks about, the actual chemistry and the functional groups and how it works as a true silicone formulation. It is true silicone. It is the cross-link reaction is a little bit different than what you typically would see with the platinum cure silicone functional groups, but it is a 100% silicone material, with the exception of the photoinitiator, which we still need in our printer.
Another question about elastomers. Can you print custom O-rings with flexible resins, and how would it compare to traditional O-rings?
Yeah, so flexible resins, assuming either are elastic 50A or flexible 80A, these two are still acrylate backbone. And if you compare to traditional O-ring, which oftentimes is being made in silicones or some of the rubbers, it really depending on what you're trying to seal. So if you're trying to seal out some solvent chemicals, and you have to look at the chemical compatibility, the temperature that you're looking to sealing at, and so conceptually it should work, but it really depending on the actual application, the situation is you require certain compression set at a certain temperature. Do you need the gasket to remain soft at cold temperature? All of that would affect if the flexible resins can actually work in the particular application.
How would silicone 40A resin compare to the ones that you just mentioned, flexible 80A and elastic 50A?
Yeah, so silicone 40A is softer, and so it will get more compression out of it. It is more chemical resistant. It is more temperature resistant. It's similar to silicone. It doesn't get stiffer when you get colder. It gets softer and you get hotter, and so it would be a little bit more consistent through a wider temperature range.
Speaking of temperature ranges, we had a bunch of questions about what material might be best for various ambient environments. So I'll put a couple of those up here in order. So Jack asked, what's the most suitable material for a fixture or jig that must withstand high pressure? Oh, I misread this one. I thought it was temperature, but we can start with this question anyway, and exhibit minimal deflection.
Yeah, so right now in the portfolio, it will be the rigid 10K, which is our stiffest resin that's filled with glass, unless you want to go the alumina, pure, fully sintered alumina route. Yeah.
And as for questions about pressure, we do have customers using rigid 10K resin for injection molding.
Yep.
And so those parts are, it'll also depend on the geometry of your parts, but those parts tend to be pretty bulky, thick, solid parts, and those can withstand decently high pressure. Okay, now we'll go to some other ones about environmental considerations. What's the most suitable material for outdoor use? High impact strength, UV resistant, which is going to be an issue for photopolymers, but I'm sure Sharon will have suggestions for how to mitigate that. Low cost and possibly could be colored.
Yeah, so right now I think it would be the new TUF 1500 V2. We've taken steps in formulations to improve the impact strength. And people talk about impact strength or talk about toughness. We've looked at the toughness through many different ways. Oftentimes, your IZOD is not the most representative, so we started looking at some of the other testing methods that has better correlation to toughness in various different applications, such as if you have to do like tap and drill, or if you have to have thin parts that is actually not going to snap. And so it also has improved UV resistance because of the formulation work that we've done. And color is a little harder today, but I think, just like all of our other resins, it can be spray painted or painted to different colors. Yeah, and we also found to further improve UV resistance, there are some clear coats, spray-on UV clear coats that can also prolong the UV aging for all of our resins.
Mm-hmm. And so the materials that have that Sharon cited, like TUF 1500 V2, because they are acrylates, acrylic paint works really well on them. You can do a priming step, but acrylic brushed paint or spray paint works pretty well. And if it's opaque enough, that could have the benefit of adding some UV resistance as well as color.
Yeah, and also from an outdoor perspective, I think depends on where you are outdoor. When it gets really hot, I do think even for top 1500 V2, temperature could still be a barrier. And so the HDD is improved, the thermal resistance is improved, the creep performance is improved. But if you're in Arizona, it's still not. It's still too hot for most of our resin or even some thermoplastics.
On the other end of the temperature spectrum, what material would you recommend for low temperatures, minus 80 degrees Celsius freezer?
Oh, depends on if the material is going to take any impact or any like deflection at that temperature. If it's just a part on its own, I think in general the parts will get more brittle as you lower the temperature. So again, I think it's depending on what will the part see during that temperature. This is where the silicone will still work pretty well. So,
do you have any tips for how you would get more stability or less brittleness at this extreme of a temperature?
At this temperature, I think pretty much all of our resins is going to be pretty stiff. This is something I think really depending on what you're looking for, this could be something to look. I think you will have maybe a better shot for like SLS materials.
Cool. Does Formlabs have a material suitable for both very high mechanical stresses and ESD protection?
Today, we only have one resin that is developed for ESD protection, which is our ESD resin. We don't have another material that can do both right now.
I will say the ESD resin that we do have is more comparable in mechanical properties to like the version 1 of the TUF 1500 than it is to a GP resin. So to Hunter, who asked this question, take a look at the ESD resin technical data sheet, which is available on the Formlabs website. And yeah, feel free to reach out to our team with follow-up questions too. A couple questions about rigid 4000 and rigid 10K. Can you talk a little bit about homogeneity of the glass-filled particles in these materials?
Yeah, so these glass particles are pretty small, and in the formulation process, we definitely spend quite a bit of time making sure that there's no agglomeration that will happen. When you have, say, you're printing with these materials with maybe like close to a month, you will start seeing some particles settle to in the tank, but we ensure with the wipers that it's part of our printer. Through that you will pretty easily resuspend them, and so there are a lot of work that has gone into making sure that the fillers are suspending uniformly in our resin. And obviously, if you have a cartridge that's been sitting there for a long time, you need to shake it up. But in normal use, if you're following the instructions, the homogeneity is very good with these two resins.
Somebody's wondering about the heat resistance specifically, and they are looking for something similar to PEEK.
Yep. So our photopolymer matrix in general, when it goes, I think around 200 degrees Celsius, you will start to degrade them. Basically, they will burn, and so it's not going to reach like what PEEK can typically do, which is like well over 250 C roughly for continuous use. And so you will see our parts turning brown, turning more brittle, started to burn at those temperatures. But if you're looking at like sub 200, like 100, 150, these materials will work pretty well, especially rigid 10K.
And they'll also behave differently depending on whether it's ambient heat or like directly applied heat as well, right?
Meaning like if it's being burnt or?
Yeah, I'm thinking about a part operating in an oven that's at 400 C versus being proximate to a like point source of heat that's at 400 C.
Sure, that's for sure. Yeah. Yep. And then like duration matters as well. You know, a lot of injection molding is pretty high temperature, pretty high pressure, but it's for a short period of time.
Yeah, great point. Great point. Especially if there's like cooling channels or something incorporated. One more question about rigid 10K. What can be done to reduce the risk of cracking, part thickness, geometry, stuff like that?
Yeah, so I don't know what very high heat means here. But if it's, you know, if the cracking is because of thermal expansion, meaning like because the temperature rises too fast and certain parts are already expanding and through the thickness, it could crack. We don't see a lot of rigid 10K cracking internally. So I don't know if I have a great answer here to help. Yeah, but in general, we've seen like if you have thicker parts and your heating is less even, you could crack due to thermal expansion at local spots.
I would say other design, like part design considerations that apply to plastic parts in general would apply here as well. Like put fillets in corners, draft angles,
Sure.
Reduce those like concentrations of stress within the part. Okay, a couple questions about post-processing. Do you have recommendations to get crystal clear polishing with clear resin B5?
Crystal clear polishing. I don't have a specific recommendation. We definitely do like polishing here internally, but we probably use our dental polishing setup here that actually works pretty well. This might be something, I don't know, Liza, maybe we can follow up with what Henry did to mimic those glasses.
Yeah. I actually
great.
know a little bit about this as well. So as Sharon mentioned, we have a dental lab inside of our office because we work with so many customers in the dental industry, and they have basically like a polishing wheel with particular polishing compounds that are used in that in a lab environment. I'm not sure exactly what they are, but it's like a buffing wheel and a polishing compound works pretty well. You can also clear coat or dip the part you can actually use liquid Formlabs resin to dip it in. You can also use some like clear coats, UV blocking clear coats as well will prevent yellowing of the part over time. Another post-processing question, how do you cure parts that have small internal fluid flow passages? And is there a material you might recommend?
Like microfluidic devices?
Yeah, that I think is what the question asker is getting at. I don't know about curing, but I know one thing that we'll do sometimes is use a squeeze bottle with isopropyl alcohol or whatever your solvent of choice is to flush internal passages. And also use a clear resin, whether it's clear resin B5, Biomed Clear, Biomed Durable is a little translucent. You can visually inspect the parts and make sure that you've washed all the residual resin out, and that also will transmit the light into the interior of the part during curing.
Yep.
One person is asking if we have specific primers to recommend for specific resins. Not to my knowledge. Do you have anything or like any components to look for or look out for in a primer?
No, I don't think I have anything specific. I don't know if we have something on our websites that talks about specific application.
I think there is. I think on the if you go to support.formlabs.com, there should be a tutorial article with information about priming and painting parts. A couple questions about biocompatibility. This question is specifically, is biocompatibility affected if the part is not post-cured? And maybe more generally, would you like to talk about biocompatibility of materials and workflows among SLA materials?
Yeah, so biocompatibility definitely can be affected if the part is not post-cured. For all of our biocompatible resins, either it's a dental resin or biomat resins, we've gone through all the testing with a specific workflow to guarantee the safety of the parts after it's been post-processed. We actually talk very specifically about how long you should wash and how clean of IPA. Sometimes it's a two-stage washing process, and then post-cure with specific temperature and duration. This is because biocompatibility hinges a lot on how cured and how cross-linked your material is at the end. And as I talked about earlier, our polymer is not fully converted coming out of the printer. You can tell it's not, the stiffness will continue to increase as you go through the post-cure. And so you definitely want to follow our post-processing instructions, because then that would tie up all the loose monomers that could still be linger around in your green parts, and those like unconverted and cross-linked like ingredients are often what will harm the biocompatibility of the part.
Great. Oh, I lost my other question about biocompatibility. 1 second, please. Here's one. Is silicone 40A biocompatible at all? And does the use of the special crosslinker affect that state?
Yeah, let me take a quick look on the updated TDS. We just did a round of updates on the TDS not so long ago. And let me see if we have included all the...
There's also, while you're looking at that, there are also different levels of biocompatibility for like skin contact versus mucosal membrane versus permanent implant, and it depends on the duration of exposure to that tissue as well. So some materials, and I think this may be true of silicone. Go ahead.
Yeah, so silicone, so there are multiple things in what Eliza was talking about. When you're looking at a specific medical devices, the medical device has a very specific use case to treat a patient. With that particular medical device code, there are specific biocompatibility testing you have to pass to make sure the device is effective and it is safe for the patient. We also have a line of materials, the biomedical materials, even including a couple of our general resins that we talk about it as a general purpose biocompatible resins. In those cases, we typically test it for a very generic set of testing, which typically gives you short-term mucosal membrane contact and long-term skin contact biocompatibility. For those, typically what goes into it is you need to pass 3 tests, which is cytotoxicity, irritation, and sanitization. And so when you pass these 2 tests, in general, the material will be good for short-term mucosal membrane contact and long-term skin contact. In the case of silicone, I just cross-checked the website. We've finished the testing, and so silicone 40A is good for long-term skin contact biocompatibility. The 3 testing results have been updated on our TDS. And then the crosslinker does not really affect the biocompatibility. The resin is really for people who want to use it in other applications, you may need to do additional biocompatibility testing on your own. But as the testing results that came back from external lab, it is good for long-term skin contact.
I'll also plug the Formlabs Regulatory Affairs and Quality Assurance team is super responsive, very professional, and they'd be happy to talk to you about specific applications and connect you with other customers who maybe have gone through approvals process for similar devices. How about Tough 1500 resin V2? Is that suitable for skin contact? And if you need to double check, I can confirm it is available for purchase now.
Yeah, it is above. The testing for skin contact is still in progress, so we're waiting for the results to come back. It is something we are in the process of testing.
Great. Follow-up question on silicone 40A. What kind of cure? None
of these.
Trade secret?
Yeah. Oh, it's on the patent, so. It's, okay. Yeah, it's still photo cure. There's a photo inhibitor in it. We are able to find a way to get the cross-link reaction to happen fast enough in the printer. And so photocurable silicone do exist, but they typically take a long time, a lot of light, which makes it really hard to make it work in our printer. But we were able to find a chemistry pathway that allows it to work in our printer. We had to take some regressions, but for the most part, it's a true silicone. It performs very much like the true silicone, and you can print it in any shape that you want now. So yeah, it's none of these.
And check out the patent. Can you talk about the process we use to measure accelerated aging? The answer to your question is yes, there's an ASTM test for this. But
yeah, so
Sharon, I'm sure can share more information.
Yeah, so I think with Top 1500 V2, we spend a lot more effort in addressing, the general complaint with photopolymer resin, which doesn't last because of the UV degradation. And so on the Top 1500 V2 TDS, you now will find UV aging test results as well. There are, in general, two type of ASTM standards. One is for indoor UV aging. One is for outdoor, which outdoor includes, the wavelengths is a little different, and there's also a water spraying component to it. Outside of the UV aging, accelerating of the two ASTM methods, we also do heat aging internally, which is typically put it in an oven for ADC for up to maybe 4 weeks, 6 weeks. And so there are different type of aging that we do internally to help assess the long-term durability of the material. And so, yep. And if you want to, sorry, go ahead.
Oh, I was just going to say the TEP 1500 resin version 2 TDS will have the most current protocols because that's the most recent material that we've released.
Yeah, it definitely includes the ASTM standard that we use on the TDS. I don't have the number on top of my head.
Yeah, me either. Are there any Formlabs resins that have hydrophobic surfaces?
Top 1500 is pretty good for hydrophobicity. There is a place where you can get so on all of our TDS, we have solvent compatibility at the very bottom of our TDS, and we definitely do water soak as part of one of the solvent. Water is one of the solvents, and so by looking at the water absorption for a particular resin, you can get insight into how hydrophilic it is. You can also cross-reference IPA, which is kind of another more aggressive another indication.
There's another question about water contact. Someone has tested various resins that go soft after a few days in water. Are there any that you would recommend? And would it be the same answer as in the previous question?
Completely soft. Yeah, so I don't know what resin's been tested here. There are a lot of lower cost resins out there using monomers that are very, very hydrophilic. In our resins, I'd say I have a hard time seeing rigid 10K being really, really soft after a few days of 2 months of water. So, but again, it's like the temperature of the water as well. I think, yeah, TDS for the solvent compatibility will give some insights into which resin might do better. And then I think also, what does keeping physical property means? Are we looking for a certain stiffness? What specifically the application is? We don't really formulate specifically for submerging in water as an application in our resin today. There's some interesting one actually to look could be in the dental resins, because that we do spend a little bit more effort since it's in your mouth. So like our denture teeth, we definitely pay attention, making sure with water soaking it doesn't get softer. And so that could be actually one place we do formulate for 37C constant water environment.
That is a fascinating comparison to have made.
That we need to make sure because, yeah, it's very important for the application.
A couple questions from someone who is looking to make their own polymer nanoparticle composite suitable for SLA printing. And they also submitted another question. Are there any recommended polymers for blending with nanoparticles?
Polymer nanocomposites. Couple of things come on top of my mind. Scattering cannot be too bad. If you have nanoparticles, you really have to care about if the nanoparticle is scattering as you print. If your particles are very scattery, you're going to have pretty poor resolutions. Second thing is agglomeration. You need to be able to disperse well. Third thing is your nanoparticle needs to bond well to your polymer matrix. To be printable, nanoparticles tend to increase your viscosity pretty dramatically because of the surface area. So you also need to make sure that your viscosity is in a printable range for whichever printer you're putting it on. So that's a very general take. I don't know what the application is, but that would be a few things that's just on top of my mind.
Great. My suspicion is that this person is a researcher as well. Is there a Formlabs material you would recommend for creating cushioning and durable footwear, like a midsole with Formlabs SLA printers?
Yeah, so for a midsole, I think our rigid 650 midsole, not a cleat. Midsole is it is the rebound resin. It was developed specifically for that application. For rebounds, it passes all the testing as a footwear midsole.
Can engineering materials be nickel plated, or can you talk about electroplating of SLA materials in general?
Yeah, I think that has been done by other customers. There's no, I think all of our resins in general, unless you go to some of the highly filled resins, they're all going to be plated pretty equivalently. And so I think there have been customers pretty successful in plating, electroplated our resins.
Yeah, I think we've actually had rigid 10K be plated successfully as well. I highly recommend a company called Repliform in, I want to say Delaware or somewhere in the US mid-Atlantic. Sean at Repliform has done a ton of research on electroplating SLA printed parts. He's a longtime collaborator of ours. He is a wealth of knowledge. Yeah, highly recommend checking out some of his work. Has Formlabs identified resins that will react to acetone vapor for getting a seal or sheen on the outside of the part? I'm gathering this person has maybe worked with vapor smoothing of SLA or SLS or FDM parts before.
Unlike thermoplastics, the resins are cross-linked, so they don't really melt. They typically break down and or swell. And so I have a hard time imagining it seal because that's more like a melting behavior than our parts. Like acetone can swell many of our resin even after it's being post cured, but I don't know if it would create the sealing and or sheen effect. Most of our resins react to acetone pretty similarly. So, but yeah, I just don't know if there is that we're gonna get that sealing effect like we do with the vapor smoothing on SLS parts.
Yeah, so I think the answer to your question, Dan, is no. It doesn't mean that it wouldn't work, but we haven't looked into it because we suspect that it probably would not, or that you could get the same seal and sheen more easily with a coating, like a spray coating or a dipped coating, would be my guess. Another question about what we report in TDSs. They see ultimate tensile strength, but not yield strength. Do we report on this?
We do not today for all of our materials. I'm going to go back to the top 1500 V2. So that is that we are going through our upgrades on our engineering materials as well as TDS, and we definitely want to include more information on our TDS. And so for top 1500 V2, you do see that we report yield strength as well. And so going forward, as we versioning up more materials, that will be the information that we would start reporting.
Someone has a follow-up to the nanoparticle question. Do you know if Formlabs sells a suitable resin for blending in these particles, or do you have other recommendations of where researchers might look?
We do not have a resin that we typically tailor the particles and the resin together to make sure that they play well. And so today we don't have a particular resin that will work with all the nanoparticles. Oftentimes, we do add dispersion and or other things to help suspend and not agglomerate. And so, like, short answer to this is really depending on your nanoparticles, what kind of like methods that you have to go through to suspend them, and then what is the affinity of the particles? What else do you need to do to keep them apart? Internally, we've definitely see different formulation base placed differently with different surface functionalization of the nanoparticles, and so it has to be designed from both sides. There is not going to be a universal resin matrix that will play well with all kinds of nanoparticles.
That makes sense. Is there a defined limit on how viscous resins can be printing with open material mode?
We don't set a limit, but if you look at the printing process, there are multiple things that could stop you from being successful, and there are also ways to mitigate that. If you have a very viscous resins in your first motor move, which is where your bell platform is coming down, you have to squeeze out the liquid. Then you run into whatever the mechanical limit is in deflecting and all that. With viscous resin, you can wait much longer for the fluid to stabilize. Otherwise, you will have fluid flow happening while you're applying the light, which then gives you pretty messy results. So there are ways to mitigate the squish move, which is higher layer height. You're gonna be having a much better pressure if you're doing 200 micron layer height, 150 micron layer height versus like a 25 micron layer height. And then obviously your resin has to then be tailored so that the light can actually go through whichever layer height that you choose. If you can get away with wiping, that will also help you with printing with viscous resins. Our wiper is pretty robust, can probably move through viscous resin as well. However, the wiping motion with viscous resin often causes like trapped bubbles, which then could ended up in your parts. And so you could consider taking that away. We don't have a defined limit. Internally, I think the most viscous resin we ship on Form 4 today is probably around 9,000 centipoise, which is silicone, but that is not the limit of the machine.
Okay, we've got a little under 5 minutes left. I appreciate the tone of this question. What is the most toxic resin in the Formlabs portfolio, and what type of PPE would you recommend for it?
We can. So every resin has its own SDS. Please read it and make sure the PP is being used appropriately. We in general do not design our resins that requires like respirators or something that is really bad from like a skin corrosion perspective. There are some specialty resins that does carry a slightly higher warning on skin corrosion, which means you should cover up yourselves and not be in contact with the resin, and that's specifically for a very specific purpose. But typically internally, safety glasses, gloves is what we do for all of our resins. We still think it's always a good practice to run your printers, your post-processing in a well-ventilated space. If anything, just because IPA and high concentration do cause people to have headaches and things like that. But from a resin design perspective, we actually pay a lot of attention to make sure that we don't use toxic ingredients. We also pick raw materials with higher purity. Some of the lower cost chemicals do have higher percentage of like MMA and small molecules that is actually pretty bad if you expose to it for a long period of time. So our SDS are going to tell you everything you need to know about a specific resin. There's no one super toxic resin that come to my mind right now.
Definitely. A few other words of safety a few other words on safety while we're on the topic. Certainly, most 3D printing resins are skin sensitizers. So like internally, we always use gloves handling resin, and I would always recommend wearing gloves when handling resin. But we run our printers in like an office space. It doesn't need to be dedicated lab space. It doesn't need to be under a fume hood. And the other, you didn't ask about this, but the other safety or EHS aspect that I see come up a lot is disposal of solvent, whether it's IPA, isopropyl alcohol, or another solvent that's used to wash the parts. We also sometimes get questions about why we don't give specific guidance on how to dispose of used IPA, and that's because it really varies from not just country to country and state to state, but like city, municipality level. So the in terms of disposal of both resin and isopropyl alcohol, unfortunately, the most specific guidance we'll be able to provide is check with your local municipality of how they'd like you to dispose of that waste material. And you can send them the SDS and they can read that and advise you. Okay, we've got 1 minute left. Rather than picking a specific question, we got a couple questions about cross-compatibility of different materials to different printers. Like we have a Form 3+, will it accept all Form 4 resins? Actually, why don't we, oh, it's already 11 o'clock. I guess I've introduced the topic. We can answer this question and then start to wrap up. Do you want to go ahead, Sharon?
Yeah, so Form 3+ won't accept all Form 4 resins. specifically, with Form 4, we've able to use the new printer hardware to open up, some of the formulations that traditionally are having a harder time to print well on 3+. And so, for example, the new GPV5 resins as well as the top 5000 V2 resins will have a hard time on 3+.
I'll also mention the cartridges are a different shape, and some of the materials have slight modifications in the formulation. So when in doubt, double check, but you should plan to purchase resins from the Formlabs website that are, or from your local distributor that are specifically for the Form 3 generation. Okay, we are at time. Thank you so much to everybody for joining, for asking your questions. Thank you, of course, to Sharon for answering the questions, sharing your many years of experience and knowledge with us. There are a number of questions that we did not get to, and so give us a couple hours, we'll distribute those questions, and hopefully somebody from Formlabs will be able to follow up with you guys offline. Thank you so much for joining. Have a great day.